Now we want to figure out what happens when this index is a 4 or 5 or a 6 or a 7. What happens to the shape of the graph? What does it look like? Now you can do this on your graphing calculator. You can do this on your TI-84 calculator. You can graph radicals. You're going to go to the nth root command on the math menu, and you'll be able to graph those radicals. Or using the Desmos graphing calculator, you go to functions and miscellaneous to get those, all right? And so that's what we've got here, all right? So if you're using the handout, there's a QR code if you want to go there. You want to get this picture here, this graph set up, or you can just go to desmos.com/calculator, or choose a graphing calculator from Desmos there, and you can just type this in. Okay, if you type in y equals, and you go to functions and go to here, and then if you put a letter like in there, or let me choose, well, let's go like this. Let me back that up. I want that back. Anyways, okay, you can build this for yourself. Now, one thing we got to watch out for is that n has to be an integer. So in Desmos, you can explore it. You can get these sliders. And so anytime you put a letter in there, it'll ask you if you want a slider. And then you'd have to set up your slider like this. Okay, or just let's check this out here. So watch what happens here. Okay, it's nice to know that you can do this yourself anytime you want. But watch what happens. This is the square root. So we're taking that 2 and putting that up in the end. So this graph here is the square root, the second root of x, okay? What happens if we take that and we move it to a 3? There's a cube root of x, and that's kind of what we expect there. We've seen that. We've built that. What about a 4th root? Well, there's your 4th root of x. It goes up real quickly and curves kind of like a square root. What about a 5th root of x? Well, look at that. There's the 5th root of x. Looks a lot like a cube root, but it's just real steep. It's not actually vertical. It just goes up real fast in that middle there. It's close to vertical. Okay, 6th root, 7th root, 8th root. Do you see a pattern going on here? 9th root, 10th root, 11th, 12th root. Okay, so we see a pattern. Anytime we have an even root, it looks like a square root. Anytime we have an odd root, we get that S curve like a cube root. Okay? All right, so if the index is an even integer for y equals n to the x, we're going to get something that looks like this. If the index is an odd integer for y equals the nth root of x, then we're going to get something that looks like the cube root. Let's try that again. Okay, it just gets a little steeper in the middle. Okay. Now, one more exploration here I want to see here, all right, because we want to see this important connection, all right. I'm going to take this back to a square root here. Okay, what happens if we take inside, and I'm going to add, I'm going to add a number. Let's add 2. Well, that's kind of interesting. Or if I add 3, or if I add 4, what's happening to the curve? Can you see? It's going off to the left. What happens if I subtract 2, subtract 3, subtract 4? See what's happening? It's moving over to the right. So if we add or subtract a number on the inside, that's going to move it left or right. Okay? So, all right, let's make a note of that. We call these transformations. And so if we have y equals the square root of, let's say, x plus b, then that b value moves the graph left and right. It moves left if it's positive. Oops, sorry. Yeah, that's absolutely right. If it's positive, or right if it's negative. All right. Okay, so what happens here if we take that? All right, let's get rid of that 3. Let's just put it back to square root of x. What happens if we have plus 1 outside the square root? Plus 2, plus 3, plus 4. See what's happening? It's going up, huh? What happens if we do minus 1? Now notice the shape is not changing. Minus 2, minus 3, minus 4. Shape is not changing, but the graph is moving. Okay, so it's going down 4, right? So if we have a plus c, the c is going to move the graph up and down. Okay, so that moves it up or down, up for positive, down for negative. All right, and we can put those together now. Let's try that out. So if we put those together here, and we have plus 1, whoops, let's take that out of there, okay. And let's say on the inside I do minus 3. So the minus 3 moved it right 3, and the 1 moved it up 1. And the shape's the same, okay. The shape is still going to be going through 0, the starting point, and then over 1, up 1, because the square root of 1 is 1. Over 4, up 2, because the square root of 4 is 2. Okay? So, the shape stays the same, it just moves. Right? That's kind of cool. Right? And what if we make it plus? It moves left. Okay? Now, one more thing to investigate real quick, and we'll wrap this part of it up. Okay? We have, let's put a number out there like 2. Oh, look at that. 3, 4. So what's happening there? Well, it makes it goes up steeper. 5. Okay? So on and so forth. Okay? So we can also put a number out in front, and that will change the steepness. Okay? So A changes the steepness or what we call the rate of change. So this A value, we're going to put A out in front. And it can flip the graph also if it's negative. All right, so let's look at that there. What if we put a negative number in front? If we have like -2, ooh, -1, or -2, or -3. See what's happening there? Okay, so negative will make it go upside down and do that. All right. Well, what happens if it's a cube root? Okay, well, cube root, we know it looks like this. Okay, so let's see what happens here. If we go inside, -1, -2, -3. Okay, see how this starting point, which used to be back at 0, 0, is moving? Oh, look what happened. I didn't even notice that. I wasn't deleting right. Anyways, you see how it's moving over. Okay, -1, -2, -3. Okay, and if we go +1, so the same kind of movement. All right. And if we do it outside the graph, +1, +2, +3. See, it's moving up. Okay. -1, -2. All right, so you can explore this on your own, all right? And if we put out in front, ×2, ×3, ×4, yeah, it's just going to take that graph, still got that S shape, but it kind of goes up a little steeper. And if we put a negative out in front here, negative will flip the S around. See that? -2, whoops. Let's go equals -2, -3, -4. Okay. All right. And I'll show you one more really nice thing here in Desmos. You can take and you can type in this A plus B plus C if you want to experiment with this on your own. And it will ask you if you want to add sliders, and we can add sliders. And now these numbers get put in there. So if we make this 0, let's see if I can make that 0. Okay. Maybe we'll make A1. Okay. So you can explore this and notice, okay, what happens when B is the number that moves it left and right. See that? C moves it up and down. And A changes the shape. All right? So there it all is. Okay. So we'll see that a whole lot more as we look at some other functions, okay? And we saw an example of a radical function in our last lesson. Here's another application of a radical function. Here's a function that gives a contractor or a carpenter the length of a rafter. A rafter is a board that holds a roof up, and we can find that length if we know the width of the house or the roof there, how wide it is, and we know the slope of the roof. So we can use this. Let's say we want to find the slope of the rafter. If we have 240-inch building, and we know the rafter length is 140 inch, so we can plug that into this. 140 is L. We know the width is 240. And we want to solve for S. So this is kind of, so here's an application of a function, kind of going back to our last solving the radical equations. Okay. We could solve this up. We get 140 over 120, and I'm going to just leave it like that for the moment. And we got a square to get rid of that exponent there. And so we have 140 over 120 squared equals S squared plus 1. Let's subtract 1. And we can square root to finish it off. And now we'll go figure that out. We have the square root of 140 divided by 120. And let's get in there. Square that, minus 1. So you can see if the numbers are reasonable enough there, just kind of keep it all together. That works nice. And we get about 0.6. So the slope is about 0.6. So, 6 inches for every 10 inches there, roughly. All right. So anyways, radical functions can be applied in several different ways. And they do show up in things like pendulums and things dealing with right triangles and stuff like that. So, all right. So those are how we graph and apply some radical functions.